Okay, we're going to start out with the problem that we did together, which was the x double dot plus 10x equals sine 2t. And we solved that down and got this final equation doing our Laplace transforms. So we're going to start by going ahead and plotting that equation. I've set up a time counter that goes from 0 to 10. My function here, which is, if you look at this, let's see, unfortunately you can't see it. Let me see if I can shrink it up a little bit here and bring this up. Okay, here we go, down the bottom. There's the function right there. You can see 1 minus 1/3 square root of 10 sine square root of 10t, 1/6 sine 2t, and cosine. So I've pretty much got that correct. And let's go ahead and plot that. Okay, and there's the plot. Looks pretty good. Okay, we'll just kind of pull this off to the side, but now we're going to go ahead and do this with a Simulink model. Okay, and so we'll open up a Simulink model. And oops, let's zero that out, and we'll bring the Simulink model up here. Let's get rid of this one. This is another one. Oh. Okay, and we're going to build that exact same model. So as I showed you before, okay, commonly used box. I'll need 2 integrators. Go ahead and do that. We're going to need some gains here, so we'll pull those out onto the here as well. We're going to need a summing block, and we do need a source block, and we're going to need a sine wave. Okay, so, and we're going to need last but not least, sinks, we're going to need a scope so we can look at it. We could also drop that off to a file. So we'll go ahead and start connecting these up. Let's move this a little bit closer. Okay, we want to switch this so that we get our feedbacks come back. Okay, we'll put this right in here. We'll turn this gain around, flip it, flip the block. Okay, and that's our gain coming back from our, in our case, this is coming back from our damping. And this, in our case, it was 0 because there was no damping in this model. But we'll include it here because then it's easy for us to change it. Let's flip this one too so it looks right. There we go. And this is our gain coming back from our displacements. And that was 10. Okay, we've got that. Oops. It helps when you put in 10 and not 10, 10. Okay, and so our initial conditions for our problem were x sub 0 equals 1 and x sub dot 0. So that's the x dot 0. This is the x 0. So that's going to be 1. Okay, and our sine wave, our sine was 2t. Frequency was 2. Okay. And let me see, do I have everything? I think I do. Let's just go ahead and run it. And let's bring that up. Let's bring the scope up. Take a look at this. Okay, let's move that up and let's make that look real nice. And let's bring back our plot that we did before. And in a couple of minutes, I've duplicated these results with just a simple Simulink model. Now I could actually go in here and change this gain to C. Okay, and we'll change this gain to K. Okay, and we'll change this frequency to W. Okay, and let's go ahead and bring this back up, and we'll put in K equals, what was our second problem? It was K equals 4, C equals 1. and we use a cosine t, so I'm gonna have to go and actually modify that. So I'm not gonna do that. So I'll just I'll make one that's similar. We'll let omega equal, or w equal 2, as it was in this one that we just did. Okay, now we're ready to go. We can come back here, grab this, run it again, and that's the results for that system. And it's just that simple. So I hope this helps some folks out. You'll have to let me know in class next week. That's it for tonight.